Good morning to all. So now we are going to see about the combustion process that is taking place in spark ignition engines. So spark ignition engine means petrol engines. That is the technical name for petrol engine. So what is combustion? So it is a chemical process. So it is a burning process. So in atmospheric air we have oxygen and nitrogen. So oxygen is available in 29% and nitrogen is in 71%. So approximately for 3.76 moles of nitrogen we are having only 1 moles of oxygen. So this is the major proportion of atmospheric air. So we are taking this as atmospheric air, oxygen and nitrogen combination. So the combustion process is nothing but it is the burning process or chemical reaction that is taking place between hydrogen and carbon in the fuel with oxygen molecules. So generally all fuels are hydrocarbons. So both the reaction, the combustion process is taking place. In other words, we can say that the chemical energy is converted into heat energy. So if to burn a process, to burn a air and fuel mixture, what are all the conditions that is required? So 3 conditions are necessary to complete the combustion process. The first condition is the presence of a combustible mixture. Combustible mixture means we are having a carburetor. So that is a device used to mix air and petrol, atmospheric air and petrol. So before entering into the engine cylinder, we are having a carburetor that produces a homogeneous petrol air mixture. So that is a combustible mixture. So the first condition is satisfied. The second condition, initiation of combustion. To start the burning process, we need spark. We have to provide spark. So that is the initiation. Third one is the combustion process once starts, it has to be stabilized. And the propagation, the travel of the flame, that has to be maintained inside the combustion chamber. So if these 3 conditions will be met, then the combustion process will be proceeding in a very smooth manner. This is the theoretical pressure crank angle diagram. So if we are having any health issues in our body, then we are going for some scan or some x-ray. So like that, if the engine has some problem or if the engine is in good condition or not, to know the condition we can take the pressure crank angle diagram. So this is the heart of the engine, whether it is a petrol engine or diesel engine. This is the very important point. So this is the theoretical diagram. So in the theoretical diagram we have 3 different processes. One is compression process, the second one is combustion process, the third one is expansion process. So in the compression process we are taking the theoretical process. So only air is compressed inside the engine cylinder. There is no present, there is no fuel, there is no petrol is available inside the engine cylinder. We are taking the ideal process. So we are taking the air as the working component. So only the air is compressed. So in the combustion process only the heat is transferred from some other external source. There is no fuel, there is no chemical reaction that is taking place inside the engine cylinder. So the third process, due to the heat transfer, the expansion process or the power process will be carried out. That is the third step in the PTHA diagram. So in the y-axis we are having cylinder pressure and the x-axis we are having crank angle. So this is the actual PTHA diagram of petrol engine. So in the petrol engine we can take 3 different stages. These are the 3 stages of combustion. First one is ignition lag, the second one is propagation of flame, third one is afterburning. So in this diagram, if we see the x-axis, we are having 100 to 80. That means we are taking only the center part of the working cycle. we are having 4 different strokes: suction, compression, expansion and exhaust. So 0 to 180 degree crank angle is taken place in the suction process. The second 180, that is 180 to 360, that is taking place in the compression process. The third stage is expansion process or power stroke. So in the power stroke, we are having the crank angle from 360 degree to 540 degree, and in the fourth process we are taking from 540 to 720 degrees of crankshaft rotation. So this is applicable for 4-stroke petrol engine. So we are dividing 4 different strokes, but this is the actual process. We are taking the mid of the combustion process. So the first phase is ignition lag. So what is ignition lag? A to B, from point A to point B is called ignition lag. That means once the spark is provided in the point A is the point at which the spark is provided by the spark plug. B is the actual start of combustion, that is the actual point of combustion. So in the point B only actual combustion process will start. The third step is C. C is called maximum pressure or peak pressure inside the engine cylinder. Then D is the actual combustion ending. So up to D the temperature rises. So after that the temperature starts decreasing. So these are the 4 different points. So below that we are having another curve, that is called motoring curve. So what is motoring curve? So if you are having fuel and air, that is petrol and air inside the engine cylinder, due to the chemical reaction between air and petrol, some heat energy will be released. But in this motoring curve, without any fuel, without any chemical reaction, only the air is burning. So this is called motoring or non-firing curve. So the first stage is ignition lag. So if to burn a process, to burn a air and fuel mixture, what are all the conditions that is required? So 3 conditions are necessary to complete the combustion process. The first condition is the presence of a combustible mixture. Combustible mixture means we are having a carburetor. So that is a device used to mix air and petrol, atmospheric air and petrol. So before entering into the engine cylinder, we are having a carburetor that produces a homogeneous petrol air mixture. So that is a combustible mixture. So the first condition is satisfied. The second condition, initiation of combustion. To start the burning process, we need spark. We have to provide spark. So the second one is flame propagation. So this is purely a mechanical process. So once the chemical reaction starts, then the pressure and temperature inside the engine cylinder will be rising rapidly. So this is the very important and main stage of combustion process. So this is the second stage. So first the first rise in pressure takes place inside the cylinder. So that is the starting point of the flame propagation. Once the peak pressure is reached, the combustion, that is flame propagation, ends. Flame will not propagate after that. So from B to C the flame propagation stage is defined. So in the flame propagation stage, the pressure and temperature rises enormously. Then the third stage is after burning. So before going to that, some factors will be affecting the flame propagation process. So fuel air ratio, compression ratio, the intake temperature and pressure of the air fuel mixture, and engine load and speed and turbulence. So many factors are involving in the flame propagation. So these factors will be affecting the flame propagation process mainly. So if the fuel air ratio is rich or lean, if it contains more fuel, less air, or more air, less fuel. So depends upon the type of fuel air ratio we are using. Then compression ratio, if it is below 15 or above 15, what is the intake temperature and pressure? Once the air fuel mixture is entering inside the engine cylinder, we have to consider the intake pressure and temperature. So this intake pressure and temperature will decide the speed of the flame. So the flame front speed will be affected by the intake temperature and pressure. Then engine load and speed. So if the speed of the engine is high, means some form of turbulence will be created inside the engine cylinder. So due to the turbulence, the flame propagation speed will be increased. So if the load is increased, if the engine load is increased, the cylinder pressure or the cycle pressure will be increased. So because of the increase in cycle pressure, the flame speed also increases. So these factors will affect the combustion in a considerable manner. So after burning, so once the air fuel mixture burns in the second stage, once it reaches the peak pressure, it starts decreasing. The pressure starts decreasing in the after burning stage. But some part of the fuel, some part of the unburned particles inside the engine cylinder will start burn in the after burning stage. So the combustion rate is very much reduced in this stage and it is coming to the end. So the temperature increases further. So the temperature increase is taking place in the after burning stage also, because some heat transfer will be taking place between the cylinder and air fuel mixture.